All right, time to go ahead and take a look at these homework problems. And I'm going to split this into two parts. We're going to look at the truck and the car. The car first. And we'll go ahead and jump in and do that now. So for the car, let's be clear that I'm going to divide this down the middle. So it's got a 50-kilometer trip. And as far as distance goes, it takes 25 kilometers. Let's just be kind of clear. This is a constant velocity car, so we could really do some. I'm going to just take the IB equations, just show you a little something that people don't think about. So the temptation is to use D equals RT, and that's a totally legitimate equation, but I want to just review one small thing. We have S equals 1/2 AT squared plus UT, and since the acceleration is 0, we could actually just adapt this equation to suit the car, which is what I'm going to do now. So we have S equals UT, and we have the first 25 kilometers happening at 40 kilometers an hour times time. So the first wing of this trip takes 5/8 of an hour. And then we take the second half at a speed of 80 kilometers per hour. So we can say S equals 80 times t, 25 equals 80 times t. And the second part of this trip actually happens at 5/16 of an hour. Now when we add this up, we're going to end up getting the total time for the car is going to be 5/8. Actually, I'm going to say 10/16 plus 5/16, which is 15/16 of an hour. It's a strange fraction. And that's going to give us about 0.9, so 0.938 hours out to 3 sig figs. The truck is a little bit different. The way the truck's going to work, it takes half the time at 40 and the other half at 80 as far as time goes. Here's what this means. The truck needs to cover a total of 50 kilometers, but here's the deal. It covers a distance d at 40 miles an hour over a time t that's half the trip. Now here's what happens. It covers the remaining 50 minus d at 80 with the same amount of time. So what I'm going to do is I'm going to actually isolate here. D over t for the first half is 40. 50 minus d over the second half, divided by 80, is the second half of the time. And now I can actually, sorry, I had this a little bit backwards. It's d over 40 equals t, and 50 minus d over 80 equals t. And these two times are half the trip. I set them equal, isolate d, and then solve for t. So d over 40 equals 50 minus d over 80. I'm going to multiply both sides by 80. That's going to give me 2d equals 50 minus d minus d. I'm going to get 3d equals 50. D is going to be 50 over 3. And now I can plug that into my formula here to get the time. So I'm going to get here 50 over 3 times 40 equals t. That's going to be 50 over 120 hours. And I'm getting 0.417 hours for the truck. So the truck has the shorter time.